Our next lecture in section 2.2 is to learn how to find the least common multiple. The least common multiple, or also called the least common denominator in our application, is the way that we're going to find a common denominator so that we could then build a higher term so that we could then add or subtract two fractions which already do not have the common denominators. So first, let's just discuss that one little piece of how to find a least common multiple or a least common denominator. So we're going to begin with the prime factorization. Now the prime factorization method isn't the only way to do this, but this is the only one that I usually discuss. So prime factors of all of the denominators that are involved, and if we write them using the exponential notation that I talked about earlier, it'll make our life a lot easier. And then we're going to write all the unique prime numbers in those prime factorizations. So every prime number that we see that we're going to write down. No matter how many times we see them, we just write them down one time. And then when we have the exponential notation, we can use the prime's highest exponents to then create the least common multiple. So let me show you how it's done. So we're going to be doing example number 13 over here. So for example number 13, what we have 22 and 33. So 22 looks like 2 times 11. And 2 and 11 are both primes, so we're going to write that down just like that. So 2 times 11. Now we'll do 33 the same way. 33 looks like 3 times 11. And 3 and 11 are also both primes, so we'll circle both of those. So we have 3 times 11. So now that we have the prime factorization for 22 and the prime factorization for 33, now we're going to go ahead and we're going to build our least common multiple, or our least common denominator. And I'm going to call it the least common denominator because that's the application that we're using. So least common denominator, I see up here 2's, and then I see 3's, and then I also see 11's. Now the thing that I'm doing here is I'm saying how many times is the most times I see it used in either this one or in this one. Not all together, but how many times in either or. So 2, how many times do I see it used here? Once. How many times do I see it used here? 0. So the most times is 1 time. Over here I see the 3, but not over here, so the most times I see it is 1. Now here goes the tricky one. 11, I see it once there and I see it once here. Now if I ask you which is bigger, 1 or 1, you'll say, well, 1, that's it. And that's the correct answer for this. It's used 1 time. However, you're probably going to, in application, you're going to want to put in 2 times. But this is not how many total times. It's the most times it's used. So now we can write the least common denominator for these as 2 times 3, which is 6, and 6 times 3, which is 66. Now, least common denominators, one thing that you should know, they're not small. Okay, you should know this, that they aren't small. In fact, the largest our least common denominator would be 22. Okay, so you want to make sure that that's one of the things that you don't make a mistake about. The next thing that you can also do to check on least common denominators is to see if it's divisible. So if it's divisible, and when I say divisible, I am meaning evenly divisible by the numbers anyway. And if it is, then you know that it's potentially the correct least common denominator. So can we divide 66 by 22? Yes. Can we divide 66 by 33? Yes. So it's not small. It's not smaller than either of my numbers, and it is divisible by those numbers. So it's a pretty good chance I calculated this thing correctly. And that's the process. Now let me show you just another quick way that we could see this same process. You could draw a little table out, and in this table you can draw the different prime numbers that you're seeing.